Hello, hi everyone, how are you doing? I hope you're doing fine. I hope Monday was good to you. Tuesday is normally a good day. And so in this video, I'm going to talk to you about something very interesting that every developer, I feel like every developer should have a clear understanding of what it is and what it does. And this is exception handling. So let me just dive straight into the presentation and show you why we need to have a clear understanding of exception handling and briefly walk you through some code, okay? So, okay, so the presentation is titled Stop Returning 500 for Everything. And what you're supposed to do is you're supposed to map every failure to the right status code, and then you return one clean, consistent error shape with a single global handler and zero try and catch in your controller. So if you have a try and catch in your controller, then I think this video is something that would kind of benefit you, okay? So the default one, the 500, the internal server error, this is where the front end smiles and says it's not my problem, it's the backend's problem. Okay, so a user might be trying to find a specific resource, an order, for example, but the order is not found. So we expect that for this scenario, we are returning a 500. But because you didn't do like a good job handling the exceptions, what you get is something ugly. And this ugly thing is gonna contain a 500. It doesn't tell the client what they made wrong from whatever you didn't like handle well. And then it also like leaks internal classes and paths. So that structure comes with a lot of information. You never want to give that to the user. And then every endpoint invents its own error shape because you don't have like a custom. So how we fix this is we create a custom exception. So I've not like introduced the whole concept of exceptions, but what we do for this scenario is we introduce a custom exception. Of course, you see here we are extending an API exception, which will act like a base exception. I'll talk to you about it. And then we throw it in the service, and then we have a global exception handler where we model that exception into a body that kind of makes sense to both the clients, okay? Uh, the hierarchy is simple. So all the exceptions stem from what we call a throwable, and then from a throwable we have two things. We have an error. So this is scenarios where we can't recover from, like out of memory, stack overflow, etc. So this is the JVM that broke. You can't catch that, you can't handle, you can't like come out of it. You also have the exception. So this is something that is related to the code that you've written. So IO exception, SQL exception, etc. These are checked exceptions. So under exceptions we have checked exceptions, and then we also have runtime, or what we call unchecked exceptions. And this include a null pointer exception. So when you use an optional, it kind of does away with that. Safe to say that. And then we also have the likes of illegal argument and illegal state exception. So checked exceptions. So these are things you need to catch before you run your code. So your code won't compile if you've not like handled checked exceptions. But runtime exceptions, they occur during runtime. So yep. And very important, whenever you're creating custom exceptions, is best you have this at the back of your mind. This is what you extend. You don't want to have your custom exceptions being a checked exception. That's going to be very chaotic. So checked, we already talked about the definition. So checked, they extend exception, and then unchecked, kind of they extend the runtime exception. So you can look into the Java docs, and you'll see the hierarchy of how things go like. So the compiler forces you to handle checked exceptions. There is no obligation for handling unchecked exceptions. So there is no need of doing a throws at the method level for an unchecked exception. So the signals, so these ones are recoverable and they are expected. And then unchecked are either a bug or a specific bad input. You're trying to find something, and then the exceptions are given there that we've already talked about. So in Spring, you throw unchecked and then no throws on every signature. So the global exception handler would catch them anyway. So you don't have to put throws everywhere. So this is how a checked exception would look like. You're trying to read from a file whenever you're doing IO operations, input, output. You always want to either files.read string. You can either handle this by putting a try and catch, or you put a throws IO exception. And I love this because you are delegating the try and catch to whoever is the caller of that specific method. So it's you to decide how you want to do things. And then for unchecked exception, we have here if x is less than 0, throw illegal argument exception. So this is an unchecked. There's no need for a throws keyword because it's already unchecked. Okay, so why do we need custom exceptions? So generic says something broke, but custom exceptions say exactly what happened, and that carries the data to prove it. So the name in the docs, if you have specific docs, carries the context, an ID, sorry, not a string, and then it maps to its own status code. So you might have something like a book not found, order not found, would come with a 404 exception. I mean status code. So throwing a runtime exception is very vague. So you always want to have a specific self-documenting kind of exception that shows the actual intent whenever you're handling that. We also have start with one base exception. So this is kind of how I view things. Yeah. Whenever I'm writing exceptions, I always want to have a base exception that when it comes to the global exception handler, I don't have to create a handler for every custom exception I create. So I just create one instance, and then it will be reusable because of, if you understand how inheritance works. So I have an abstract API exception which extends runtime exception, comes with a HTTP status code for me, and then yeah, a bunch of things that happen here. And then so for an order, it extends an API exception. So and then I just like pass the specific status. So each exception owns its own status. So we have one API exception, and then it covers the whole family. So you don't have to create like in the global exception handler, you don't have to handle all of them. So pretty much how the code would look like. So we have look at this code. We have an order service, private final order repository, of course, inject it, yada yada yada, and then you're trying to find an order by ID. So if I don't find it, I just throw an order not found exception, and then I pass the specific ID. So if you come back here, you'd see that I'd pass the ID, and then it would map the message that the client gets its order with that specific ID is not found, and then I also have access to the HTTP status for that scenario. And in the controller, I don't have to care about try and catches, so that I try and filter something out. Sorry, I don't have like a response entity here, but this is how I do. I just like make a simple call. I don't have try and catch. There's no status code. The controller just returns that specific order or not if it's not found. One handler that is kind of encapsulating all of these exceptions. We have the at rest controller advice. You'd find people using at controller advice. I use a rest controller advice because I'm kind of building REST APIs now. And then I have this. This is the place where I'll handle all the custom exceptions. So this is the base. I'm using ProblemDetail. I've done a post about ProblemDetail, which is like an RFC 9457. So kind of an inbuilt error response that, yeah, it's quite interesting. So you handle that specific exception, and then you return a problem detail containing the status and the message. So it knows what it needs to do because you're getting from this. So exception would get from ex.message. So if it's an order not found, etc., it's gonna handle that for me. I need to handle this well. Yeah, so that's that. We also have the rest controller advice, so it spans in every controller that you have, and then one handler for the whole family, status for the exception, and then you have a fallback plan. So you always want to have this at the end of all the exceptions that you have. You always want to have something that is backup. Okay. This I've already talked about the problem detail. So this is an RFC 9457, and it's built into Spring, so you don't have to create your own custom error responses. So before you watched this video, you probably were doing this. You probably had the 500 exposing a lot of stuff, coming with a lot of things. But after this, you have now a specific response that the client gets. So this is a 404 or 404. It's an application plus problem plus JSON. So this is like the RFC, what it returns. So the type, that order not found, etc. So this ensures that the client gets like very good information. So if you want to take it into production, so you always want to have some logging if you need to, and yeah, it just depends with how you handle your things. But ideally, using the global exception handler still, and you're still using the problem detail, you want to add the response entity exception handler. So if you extend the response entity exception handler, it brings Spring's own error, and you get like everyone will get like the same shape. So it's pretty much just like adding some more context into how you're handling your exceptions, and very useful if you want to kind of say, for example, override the method argument not valid exception, where you're using a validation, like string starter validation. So you always want to use to extend the response entity exception handler. What you get is a rich body, so it contains the type, the instance, and then the error code. So it's very very important. And then handle method argument not valid. You can override for validation, and then you can also have access to the, you can log the stack, so returning the trace ID. So if you're using distributed system, for example, you always want to get the trace ID and MDC, those kind of things. And then you flow at the exception, never at the throwable, so you're always in safe hands. So last but not least, what we are getting is, the problem is we had unhandled exceptions, leaking stack traces and returning 500 for everything. The hierarchy, very important, is you have a throwable goes to error or exception, and then exception goes to runtime exception or compile time exception, or checked and unchecked exceptions, and then you extend the last one. So you always wanna, for custom exceptions, you always wanna go for the runtime. So we talked about checked and versus unchecked. So in Spring, you throw unchecked, signatures stay clean. Very important. Very, you throw order not found. Custom exceptions, so very important. They carry the context and not just a specific string. They carry the context of whatever happened, where it happened. And then you always want to have a base exception, so one abstract API exception, and then each carries its own status. So they extend from this API exception. And then what you do is you throw in the service, and this ensures that you stay away from try and catch unless it's a checked exception. You also have a global exception handler. So this is the encapsulator of all the exceptions. So whenever an exception happens in the controller, or user hits the controller, this specific exception is being triggered, the global exception handler will do that for you. And then using the RFC 9457, which is one consistent way of standardizing the error responses. So if you don't want to use the custom error responses, by all means, you just go for the problem detail. And this marks the end of my presentation. I have some slides I think I'll share in this video as well. Not slides per se. I have GitHub repository that is dedicated to all this, talking about the problem detail, the RFC, and also the custom error responses that we are ideally used to. So thank you very much for watching up to this very end. I hope you gained something from it. And if you did, share with other people as well, so that they benefit or learn from it. Till next time, have a nice one. Bye.